In this video, we'll look at an example of what we get when we train an autoencoder on some real data. Alright, so we have this autoencoder here. It's a feed-forward neural network. It outputs a reconstruction of the input. And then we've looked at how we could define a loss that compares the reconstruction with the input. And then using that loss, we can compute the gradient with respect to the pre-activation and then backpropagate that through the network in order to do stochastic gradient descent training of the autoencoder on some set of unlabeled data. So now let's look at what we get in terms of a latent representation in terms of features if we train such an autoencoder on some real data. So we'll go back to the MNIST dataset, which we've looked at before when we talked about the restricted Boltzmann machine. So we'll train, what I'll show is a result of training an autoencoder on the same data, and we'll look at each hidden unit in the encoder and see what kind of features it extracts, what kind of representation it extracts from the input. So again, each square here is going to be one hidden unit in the autoencoder, and it's a visualization of the weight vector between all inputs and a specific hidden unit. And so gray means weight of 0, black a weight that's negative, and white a weight that's positive. Now we see that the autoencoder seems to have learned, for instance, that we tend to have either white pixels close to each other in a spatially localized region or black pixel. It doesn't seem, however, to have learned very interesting features such as stroke detectors or edge detectors. It actually has a lot of them which are mainly 0, and they're actually kind of we'd say they show high spatial frequency, but they don't seem to extract a particularly appealing and meaningful visual pattern. It has understood that pixels around that are in some neighborhood tend to have the same value, but otherwise it doesn't seem to have understood a lot of the structure that characterizes handwritten characters. So why is that, and can we improve on that? So it turns out this autoencoder can still be useful in certain contexts, and we'll be able to talk about this when we talk about deep learning. However, we will also be able to improve it, and so in the next videos I'll talk about what's a problem here that we have with this particular way of training an autoencoder, and then we'll talk about some alternative solutions.